Hello, everybody. So actually, I would make the question, how many people were here on Tuesday and saw my presentation? Okay. So I'm sorry, but people were here because I'm going to show several of the same content to introduce the project. So if I don't want to waste your time, if you want to come back in 15 minutes. Oh, no, I'm joking. Okay. Okay. So I'm Massimo Tisi, I'm professor from IMT Atlantique, and I'm coordinator of MOSAICO, that is a European project on management, orchestration, and supervision of AI agent communities. So it's about AI agents. So in this slide you can see a little example that I will show throughout the presentation, where myself, in the picture, I use an AI agent and I give a very simple task. The task is to generate a domain model. A domain model is a set of classes in practice with attributes, etc. in a particular textual format. The format is from another Eclipse project that is called Eclipse Emphatic. Then I give a little specification of the domain in textual natural language. And of course, I want this model to be syntactically and semantically correct. And of course, the task is very simple, so any of the shelf agent that I get today probably will answer correctly. You see the correct answer in the picture. But of course, you can imagine, and if you tried these agents in your work, that when you start writing a specification is much bigger, much more complex, like few pages specification, you will get all sorts of errors, syntactical errors, semantical errors, etc., because LLMs are not that good. That's why people write agents that are a bit more complex than that, and especially they have some specific logic to handle some cases. There are several approaches. I'm going to talk only about one of these approaches that is called the multi-agent approach. So in this approach, the blue agent that I used before is not directly inferring the answer, but is inferring a set of sub-prompts to delegate to some sub-agents. For instance, it can delegate to the first sub-agent, the green one, a prompt about generating the model. To the second sub-agent, it can delegate a prompt about syntactically validating the model. And this makes sense because maybe in the second sub-agent, you can equip it, you can embed some tools to check the syntax, like the emphatic parser and validator. So it can be trained to use well these tools. And then you can have a third sub-agent that is in charge to validate the semantics of the model against the specification. And of course, here you want to use an LLM that is different from the first one to raise a bit the objectivity in judging the work of the first agent. Of course, then the blue agent needs some logic to gather all the results of the sub-agents and to maybe iterate how to get some satisfiable answer for the user. Okay, this is a very popular approach today. A lot of people are doing this. Even when you launch Copilot, etc., there is some multi-agent thing going in the ground. Why? Why it can make sense? One reason is because it allows you to specialize the sub-agents, so you can make agents that are optimized for some subtasks because they have specific personas, specific tools, and they have an LLM that has been benchmarked well on that task. Another reason is variability. Variability means that you can replicate the same task a lot of times on different agents that has some difference in LLM persona or tools, with the hope that this will increase your success rate, or if you do some kind of majority voting, maybe in getting a more reliable answer. Another reason is cost. You can route simpler tasks to cheaper agents, etc. But of course, it comes with some problems. It's not trivial, but this is a positive approach in the sense that it has a lot of overhead. The more agents I have, the more the communication, the more the LLM calls, and the slower the response time. And also, it's not clear what happens with errors. They could cancel themselves in the network, but they could also amplify themselves. So there is a lot of research. Research is quite active here. And I would say that the research field was kind of positive up to 2024. There was a very discussed paper, what was called More Agents is All You Need, that was showing that with a very, very simple strategy, that is replicating the same task and the majority voting the most popular answer, you are getting some advantages, let's say some performance gains in a lot of well-known benchmarks. But okay, today instead the view on multi-agent is much more, let's say, skeptical, but in a sense more critical. There is a nice paper from Google that shows that, I mean, if you don't use any particular structure, you let the little group of agents, I think 6 agents if I remember correctly, work independently with each other. You generally don't have any advantage with respect to using a single agent when you use the frontier model, let's say the top performing model. In this graph, this will be the top Google model. You can get some advantages when you use a less reliable model, let's say, but with the frontier model, usually that's not the case. So anyway, also the setup, the experimental setup is very limited, as I said, a small group of agents in a very dynamic way. So the agents computes the collaboration at runtime. So a lot of research is still has to be done. MOSAICO is really about that. So MOSAICO means management, orchestration, and supervision of agent communities, and the purpose of the project is to enable and study the cooperation of a possibly large number of LLM agents. And the idea is, can we use this collaboration among agents to increase the reliability of LLMs in software engineering? It's an Horizon Europe project. We have 12 partners in Europe. IMT Atlantique is coordinating. We proposed this project in March 2024. The idea comes from 2023. I just say it because, I'm proud that we could foresee a problem that in 2026 is very actual. And okay, we are the beginning of the second year of the project. We, as 1 year passed and something, we have something to show. So the first thing that we can show is a client. So it at least gives you an idea of how MOSAICO looks like. The client, you can see a screenshot in the right-hand side, and it really looks like, so it's a VS Code extension, so it really looks like a Copilot somehow. So it's an AI assistant. For implementing this UI, we forked an open source project that's called Continue, that has Apache license. So you see here the same example I showed. You see the answer, and the only thing that you will see differently than what you see in Copilot is some kind of tracking of what happens of the multi-agent backend. So this is exactly the same one that I showed in the example. So I have a sub-agent that computes the model, a syntactic supervisor, and a semantic supervisor, and you can track what is their feedback, what is their evaluation, etc. So this client, we made it available during OCX, and it has already 5,000 downloads. So we are kind of happy of the popularity. And you can download it in OpenVSX right now. Of course, the client is only the left-hand side here. So it sends the prompt, but at that point starts the complex part. The client communicates only with one agent that is called the reference agent, that is this red agent here. And in MOSAICO, we have a hierarchy of agents. Actually, these are all the kinds of agents that you can have. So the reference agent typically delegates the whole task to one agent that is called the collaboration agent. The collaboration agent is an agent that has the task to devise the collaboration. I will talk a bit more about what it does later. So it computes a workflow that involves a lot of other agents that you can see here. Some of these other agents are still collaboration agents, so are still green, because that could be some task that require some further decomposition. Okay, so it's not sure that all the tasks are actionable by a single agent. So that's why the decomposition is hierarchical. But at some point, some of the tasks are given to the blue agents that are the ones that do the real work. We call them solution agents, are the ones that compute either an output or an artifact. They want to perform changes on your file system or to launch some MCP tools on the cloud, etc. So this is the blue agents. Since we try to increase reliability on the multi-agent system, the work of the blue agent is typically passed to some yellow agents that are called supervision agents. Supervision agents have the only job that is evaluating the task of the solution agent, the work done by some solution agents. That's why supervision agents typically can be replicated a lot, for instance, for having several different kinds of evaluations of a single solution. And that's why, since we have several evaluators, some point the framework needs to take decisions, and the decisions need to reach a consensus among the evaluators. The consensus can involve a debate, so it's not trivial to be reached. And we have indeed another kind of agent that is called consensus agent that has this task. So this is what happens at runtime. Then we have some two global components that are called the orchestrator and decision engine to support both the collaboration agent and the consensus agent. Finally, we have a repository. The repository stores the code of these agents, or points to the code of these agents when you use external repositories, and then performs in background a benchmarking process. So we compute metrics on these agents, and these metrics can be used by the collaboration agent to select what agent to invoke. So this is what happens at runtime. So what are we delivering? We are delivering 4 components that are the 4 colors that you see here. In orange, starting from here, we are delivering an orchestrator with the collaboration agent, the agent that devises the collaboration. In violet, in the second part, we are delivering a decision engine with the consensus agent. We are delivering a protocol to make all these agents communicate among each other, and we are delivering a repository with the benchmarking infrastructure. Okay, so what are the principles? So the point of this slide is that there are a lot of other agentic platforms. So this is just one of the agentic platforms that you will see in 2020-26 appearing. So what are the design decisions that make MOSAICO different from the others? First of all, it's a platform that is polyglot and really agnostic from the way you are developing your agents. So the whole project is about the collaboration among agents and not what happens inside the single agent. That means that the agents are isolated, each one runs in its own Docker container, and they only communicate by protocols, by network protocols. So you can use the language that you want, the framework you want to develop each single agent. And this allows us also not to compete with a lot of big actors in the market. Then the second important point is that it's a platform based on reputation. So as you saw, we are computing these metrics by benchmarking. We are also tracking the performance of these agents online during the tasks. And this has the purpose to build a reputation for the agent and to make it more suitable to be invoked the next time some similar task is needed. This really, to us, we have really this metaphor of the community. So reputation is a bit like in a community where agents somehow know each other and they know who to call to perform a certain task. Another factor that you will not see in other frameworks is explicitness. So when we go a bit more technical, we have explicit representation on one side of the multi-agent collaboration. So we have artifacts that represent the collaboration, and also that represent what the consensus agents works on, that are governance rules. But also within the agent, we suppose that the agent has an explicit representation of the mental model. Okay, we use as an abstraction for the mental model an old idea that is called belief, desire, intentions. As I said, the implementation of the agent is opaque. But in the protocol, sometimes we ask for this structure, so the agent can compute them on the fly, or it can, and this is more advantageous so often, keep them maintained in some data structures during the execution. So all of this makes things explicit, and we can then, the framework can query this information at runtime to optimize the collaboration, and that's what makes our collaboration working. Fourth point, we use languages with formal semantics throughout the platform, so all things that I talked about, we tend to represent them in languages with formal semantics and not in simple Python code or JSON files as you see in the market. And finally, MOSAICO is open in all senses of the word, I would say. First of all, we have MIT license for all the code in the platform. All the data sets, all data, and all the experimentations are published in Zenodo freely, so you can download the data sets and do your own things. All publications are in open access, and the technical reports too of the project are all public. Eclipse is a partner of the project, and the project is also open to contributor collaborations, especially we really need in the project to develop agents. So we are developing agents in the consortium, but we also ask for help from the community to start developing agents and making the platform useful. So I took some time, so maybe I will skip the technical side, but if we have time, I will go back to them. Yeah. The consortium, we have 4 universities that deal with 4 technical sides of the project. We have an integration that is Intrasoft, a company for integration. Codo is a company that is quite well known in VS Code for tools that use LLM for software engineering tasks, for instance, pull request reviews. Eclipse, I already said. FCSS deals with communication and dissemination. And we have 4 use cases in 4 different domains. And the use cases are these one. We have Immersion, that is a company that, okay, in all cases, they try to use MOSAICO to help them build some software, of course. What changes is the software. So for Immersion, the software is mixed reality content for VR and XR device. For Collins is a prediction component for estimating the remaining useful life of a component in the airplane. For Unparallel is maintenance and testing of a catalog of IoT solutions. And for National Bank of Greece is a recommendation system for investments based on user profiles. So the best way you have today to give a look to MOSAICO is to download the demonstrator. You have a URL there, and in the URL you will find also a one-liner that uses Docker Composed to download a whole bunch of things that you see in this picture and to run them. What you will download? You will download the client, the reference agent. You will download a few agents that include also the agents of my little talk, my little example. They will download the repository with its database. We download also an observability platform, Langfuse, to monitor what happens with your agents with the data storage for it. Maybe don't do it today, because I think that because of OSX we were overcharged, so now things are not downloading actually. We have too many requests, but maybe tomorrow will be better. Thank you.
Discussion, question? One? There? I need this.
Thank you. I assume you are familiar with the stuff of 20 years ago, like FIPA and the JADE platform, right?
Absolutely. Sorry, I
Okay.
really need to go here.
Do you know me? Do you know who I am?
Yeah.
JADE is my PhD thesis.
Ah, yeah,
Right.
perfect.
So I wanted to understand. So, did you fix what France Telecom did wrong with the semantics of the BDI in FIPA? So,
No.
what semantics did you use?
Sorry. So what we are doing about FIPA, and actually we are really looking at FIPA, yeah? What we are doing, so I have a slide for it. So at some point in the proposal we said we are developing a new protocol for making the agents communicate. Actually, then, let's say, industry is aligning a bit on an existing protocol that is called A2A by Google. Okay.
Yes.
So what we are doing is extending A2A with some things that we think are useful. On one side, the things about observability. And on the other side, some performatives. The performatives are taken from FIPA. Yeah. So far we are staying with FIPA, but we are looking also at KQML and.
Okay.
Because there's some things that we like there too. And the idea is that in A2A, you can have you already have some primitives for the life cycle of the task, but you don't have any primitives for the beliefs of the agent, the intentions of the agent, so the commitment of the agent to some actions, etc. So this is what we are using FIPA for, or at least the primitives.
Okay, but you are really trying to do a formal semantics that, let's say, judges admissibility of interactions based on BDI.
No.
Okay, so what do you use BDI for? Because you said that you require that an agent kind of declares, or I guess believes, I'm sending this because I believe that, right?
Yeah. So we maybe have another. Yeah. So I have slides for everything. So for instance, we try to use it to find the compromise in disagreements. Okay. So as I said, there is a notion of consensus at some point. So at some point we query the beliefs to try to find inconsistencies between the beliefs of two agents that give us a different result, and we try to see if we can come up with something that can be a compromise between them, or at least to communicate. Okay. We communicate with them to see, okay, look, you did this because the other agent has a different belief on this point. Or we use intentions to block conflicting actions, typically. I mean, this is very common because all agents try to write on your test systems.
So use it like arbitration. So sorry if I interrupt you. I don't, because otherwise I'm going to steal all the time. So I need to speak with you more. Okay, yeah. So yeah. Well, I didn't know. I wouldn't take any coffee, Rosaria, if I'd know that this was.
No, I'm so sorry. Yes. Yeah, but
no, I'm sorry because I skipped all the technical part because the workshop here is about collaborating among projects. But I think it's very useful. Yeah.
You ready, Sebastian? Yeah. Okay.